Hey everyone, I'm going to go through Regents Prep 10. So starting with number 1, compared to distilled water, an aqueous salt solution has. So I want to think here, we've got my alligator, there's his little teeth. As I add anything to water, my boiling point is going to go up and my freezing point is going to go down. So I don't like a higher freezing point. I don't like a lower boiling point. So I'm going to get rid of those with that. Now I'm down to the electrical conductivity. And if I have salts, I'm going to break into ions. So I will have better electrical conductivity. So B. 2. Which type of substance yields hydrogen ions H+ in aqueous solution? The answer here is going to be A, because I like acid. If I go to table K, I can see that all of them are going to have H's. So I'll write down table K for my explanation. That's it. 3. What can be explained by the Arrhenius theory? So Arrhenius was acids and bases. And we know that acids have H+ and bases have OH-. So the effect of stress, nope, not stress, that was Le Chatelier. Spontaneous decay, nope, that's nuclear chemistry. Behavior of many acids and bases, I like that. So C. 4. According to one acid-base theory, water molecule acts as an acid when the molecule, so let's think, they must be talking about the Bronsted-Lowry definition. And in that, they talk about accepting or donating H+, so I'm going to get rid of OH-. I don't like that. So I want to think, okay, acid. Acids have H+, so they don't accept, they donate. So A. Okay, 5. The acidity or alkalinity of an unknown aqueous solution is indicated by it. So acidity, acids, alkalinity, that means bases. So acids and bases. Indicated, think table M, indicators. So they indicate C, the pH value. 6. According to one acid-base theory, NH3 acts as a base when the NH3 molecule. So again, I'm kind of looking back up to this problem. It's Bronsted-Lowry again. It's always about accepting or donating H+, and if you're a base, you are going to accept your H+. So I like choice D. 7. Which compound is an Arrhenius base? So I'm actually going to go to table L. And I'm going to check out my bases, and I'm going to see that I see a lot of OHs, and then I might look for NH3. So let's kind of scan. I see CaOH2, so I like that. I'm going to get rid of this one, actually. I see an OH, but it also has a C, so we know that that's an alcohol. And that would be a salt, and that would just be covalent. Okay, 8. Which process is used to determine the concentration of an acid? So concentration, I want to think molarity. So I might actually lead to going back to table, let's see, table T. And I see right here, I've got titration, which has molarity in it, and I have concentration. That's where I get my molarity. So the titration equation, MAVA equals MBVB. So titration is my answer. 9. Which statement describes one acid-base theory? So a lot of times you're noticing they're saying one acid-base theory, one acid-base theory. That, again, that's that Bronsted-Lowry. So acid is an H minus. I don't like H minus. Let's look for another H minus. Nope. So acid is an H plus donor, or an acid is an H plus acceptor. So I want to decide between there. It's not an acceptor. It's a donor. And the base is the H plus acceptor. So I like B for number 9. 10. According to one acid-base theory, water can act as a base. So again, one acid-base theory, because the water molecule can. So we've seen a lot of questions like this. I don't like H minus. I'm accepting or donating H plus, and if I'm a base, I like to donate. So B. Notice those kind of questions are always kind of the same. Okay, which volume of 0.6 molar H2SO4 neutralizes 100 milliliters of 3 molar BaOH2? So what I want to think here is I have a molarity, and H2SO4 is an acid. So I have my molarity of acid. They also tell me that it neutralizes. I want to think neutralizes. Think titration. Those words go together. So I have a volume. So I have a volume here of a base, because 0.3 molar is a molarity of that BaOH2, which is a base. So I'm going to plug into the titration equation. MaBa equals MbBb. I know my molarity of my acid is 0.6. I know my volume of acid is X. My molarity of my base is 0.3. And then I have 100 milliliters. Sorry, it's kind of running out of room there. So what I would get there is X equals 50 milliliters. So I like D, 50 milliliters. Remember, I'm going to table T anytime I see questions like this. So I got my titration equation. 12. Which of the following statements describes characteristics of 0.1 molar KOH? I see an OH, so I think that must be a base. If that is a base, this looks like I'm looking at pH. So bases, pH less than 7. Nope, that's my acids. Solution is acidic with a pH greater than 7. Nope, it's not acidic, it's basic. So the solution is basic with a pH greater than 7. I like that. Let's see why I get rid of D. Solution is acidic. Nope, it's not acidic. With less than 7. It's not less than 7. So I do like choice C. So 12 is C. 13. In a titration, 20 milliliters of 0.15 molar NaOH exactly neutralizes 24 milliliters of HCl. What is the concentration of HCl in the solution?